Your hand. Should be 13 people. So if it didn't pop up on your screen, let me know.
It did, but then it closed.
You need stuff. I have it for you. Thank you. No, I'll grab it for you. Okay. I got it.
Thank you very much.
So mine opened, but then it closed.
Okay, look on the left menu. Say quick polls with their options.
I have
Yeah.
no idea. I left my binder out. It's not
Ah, what is the domain? Domain are the X values. You did. You learned it algebra 2. Algebra 2. How do you know this? You're right now.
Wait.
Oh, really? Is it just negative?
Oh.
Isn't this just backwards?
Wait, you don't even need the problem.
Or don't you need to backwards?
Yes.
No.
Wait, it's the first. No.
No, because I'm not asking for the solutions. I'm asking for the domain.
But
X values.
Wait, it's the
So
The X values are 3 and 2.
that's the solution. Those are the zeros. But I'm looking for the domain. Ready?
I really appreciate that.
I'm explaining it. So domain are the X values. So I'm looking for, okay, which represent all the X values in my domain. So can you think of an X that if I plugged it in, it would not give me a Y value? Do I have a hole? Do I have an asymptote? Maybe a jump? Remember how you learned jump? Like piecewise functions? No? That's fine, because we're about to go over them anyway.
Well, no, I'm saying like that.
So, there is none. There are no discontinuities. If you plug in an X, any X value at all, you plug it in, you will get a Y value. So the domain is all real numbers. How do you write all real numbers in interval notation? The first one.
There you go.
Polynomials, their domain is always all real numbers. If we have special things like a square root or a rational where I have a polynomial divide by polynomial, but if I have asymptotes, right? Remember how we have an asymptote sometimes? If not, we're about to go over it anyway. This is just a warm-up question. So I told you it's the first one, so hopefully we know how to submit. You go up to the top, push the drop-down menu, it says submit. Uno más, yes.
I left my binder at home, so when we take notes, I have to pull it.
I mean, I'll have the filled notes anyway online. Yeah. I don't know if I have an extra copy. Okay, so I don't know who didn't submit. I'm just going to keep going. Okay, here's the trick play. You can use your notes for it. Which of the following represents the domain? So think about, what does this graph even look like? Is it defined for all numbers? No, it's not defined for all numbers. So you know the first one's wrong. Roughly, what does this graph look like? Something along the lines of like a square root, right? Square root, remember how if you like go to a movie theater, arm around someone? Literally, you make fun of me, whatever. It's, what?
It's really funny.
Cool. Well, you'll never forget what a square root looks like.
Yeah.
What's my left arm? What's this arm over here doing? Nothing, because it's not defined that way. It's only right here. So I know if I just have square root x, the numbers I plug in, it can't be negative. So what's inside here has to be greater than or equal to 0. So if I take what's inside here, x plus 12, I know it has to be greater than or equal to 0. So x has to be greater than or equal to negative 12.
Oh, well.
If I plug in negative 13, what happens?
It becomes negative.
Negative, right? It'd be I, like
What
square
if we-
negative 1.
Wow.
You don't want that.
Why is it
Wait,
12
do we
and
get
not
grades
2?
on this? 'Cause I kinda-
Huh?
Why is it 12 and not 2?
Because the 2 has nothing to do. The 2 out here, all it does is stretch it vertically.
It's the last.
Has nothing to do with horizontal.
It's the last one.
I think it's the second one.
It's the
It's
second
one.
the bracket, yeah.
If
Yeah,
I
I
plug,
didn't do that, I did too.
so if I plug in negative 12, what is negative 12 plus 12?
0.
0. Square root of 0 is 0. Yeah, so it's defined right there. So I include that, and then it goes on to infinity. So what this would look like, if I would graph it, here's y, x, right here at negative 12, that's what it looks like. All the 2 in front, right? There's 2 in front. Originally, this is what the graph should have looked like, was the dotted. The 2 in front stretches it vertically, so it's twice as high as what it normally would have been. The 2 has nothing to do with the rest of this problem. Okay, so this is just warming you up for the rest of the lesson. Okay. You okay?
Yeah.
Okay, cool. All right, so that 12 out of 13, I told you it is the second one. All right. Oh no. Did it quit on me? Don't quit on me. Okay. Yeah, since so many people are gone, let me make sure I screencast everything. So today we are finishing 1.1 for sure. We'll start 1.2, and then I'm looking at your lesson plan right now. We'll hopefully finish it, and then have a day to review and like go over some questions that we have. So this chapter is a little more spread out. It's a little slower. And if you turn on the other side of your lesson plan, what do you see on the 19th of December? Your final. I told you the day your final. Trig play, it's on your syllabus. You signed it. You said you'd be here. 19th of December, it's your G period final. Not a trick. All right.
Wait, do we not have class tomorrow?
No, we do. We do. We have class. It's just the schedule is like shrunk a little bit.
But don't we do 2:15?
Yes, the schedule shrunk, so it's a special schedule. So you still meet every class.
Is there a reason why?
Because we have a faculty meeting.
Got it.
Function notation. So, function notation. The symbol f of x is read as f of x. F parenthesis x parenthesis, it's f of x. So literally, is the value of the function at which x value? Oh, whatever one we plug in right here. It tells you the y value for a given value of x. So literally, f of x means the same thing as y. It's just the difference is I can be more specific. So I can write the whole equation as, instead of saying like, oh, y equals 2x plus 1, I can say f of x equals 2x plus 1. Then if I want to evaluate it, find the value of y at a specific x, so let's say at 1. I can say f of 1, and then everywhere where there's an x, I plug in a 1. Not new, right? We already know this. This is beautiful. This should be a nice part of this chapter. I'm hoping you feel this chapter is like way smoother. X can represent any value in the domain of f. Oh, I messed up. The do now questions, I did it based on my other class because we got further because the whole lockdown thing. That makes sense why you guys had no clue what to do. My bad. Okay, that's fine. It's all good. I forgot that we didn't cover it at all yesterday. X can represent any value in the domain of f, and it's called the independent variable. X is the domain. Y is the range. Yeah. If you're a king or queen, and you're looking out over your domain, I don't know, do you see my hands? Are you looking out on your domain? It's the X. Okay, I know I'm extra, it's fine.
No, I love it. As a teacher wants like that.
I'm just gonna be like, domain, independent variable. The y is the dependent. Okay? No, okay, ready? If you go climb a mountain, ready? You're gonna go climb a mountain range, like the Himalayas are very, very tall. Range is the y. Or someone said, like, rangy and domainix, or whatever. That's one way to think of it. Domainix. Rangy, because rangy is with y, domains with x. There's two different ways. Just give you two ways to remember. Okay, so now let's find the value of each function if f of x equals x squared minus 2x minus 8. Are you sad you don't sit together? It's just like sending mail from across the room. Love. Okay. The f of 3. How do I do this? Plug in 3 for x. Yep. I knew what you meant. I got you. I knew what you meant. So this one should be a nice, easy, this should be the easy points on your quiz. 3 squared minus 2 times 3 minus 8. 9 minus 6 minus 8. Negative 5. So you can either say negative 5, or you can say f of 3 equals negative 5. Trying to be as clear as possible. So on your quiz or test, either one of these are fine. I don't take off points. if you don't like say f of 3. I give you a line. I want you to put the number on the line. If you don't have the negative, that's wrong. If you don't show your work, you get points off. There's points associated with every step of showing your work. So if you don't show your work, you don't get those points. What you could have done is you could put this one and that. That's fine. That's enough to show your work. That's fine. It shows me you understand how to plug it in and you have the answer. Cool. All right, let's do B. Okay, cool. So I'm plugging in negative 3D everywhere there was an X. If I'm going too fast, just tell me to slow down. Ask me nicely. Okay, so negative 3D squared, I have to distribute the squared because it's 3 times negative 3 times d. So like since it's one term, I can just distribute the negative 2 to everywhere. Negative 3 times negative 3 is 9, and then d squared plus 6d minus 8. That's it. That's all I want.
Do you not like?
That's it. You just have to like simplify it. If there was common terms, you'd have to combine them, but that's it. I just want you to plug it in and show me you know rules of exponents. Okay. Questions so far? All right, I want you to try C. So I'll give you like 10 seconds. Try out C. See if you can figure out part C. It's like my BLT comment yesterday. I was so proud of myself, and then I told the other math teachers. And they gave me the same looks you did, so that was not a pleasant feeling. Okay. And if you're done, try out D. You can compare with the person next to you. Don't forget to FOIL since you're squaring a binomial. Just sorry, I'm making sure I wrote down attendance. Okay. Okay. So let's do it. So notice I have 2a minus 1. It's a binomial I'm plugging in for x. So this is going to be 2a minus 1 squared minus 2 times 2a minus 1 minus 8. Alright. So the first one, I need to FOIL this out. Do not be lulled into 4a squared plus 1. That is wrong. Right? Because you have 2a minus 1 times 2a minus 1. I believe I covered this after your guys' first quiz. If you FOIL it out, you get 4a squared minus 2a plus 1. So it turns out when you FOIL it out, it's 4a squared minus 4a plus 1. And then this part will come from there. Minus 4a plus 2 minus 8. So I can't box this because there's like terms I have to combine. So I have 4a squared. Let's see, minus 4a, so negative 8a, plus 1, plus 2 is 3. 3 minus 8 is negative 5. Did we have any problems with this one? No? Okay, cool. If you did, like when I have you work in class, I want you to work with the people next to you. Between the two of you, feel like you guys would be pretty solid. All right, so negative 2 f of x. So what we're doing is we're literally just taking negative 2 multiplied by the whole function. So I have negative 2 times, what's my function? X squared minus 2x minus 8. So distribute it out, negative 2x squared plus 4x plus 16. That's it.
Why don't we like put in parentheses? I forget what it's called. Like, why wouldn't you distribute this more?
Simplify it more?
Yeah.
I mean, I don't have to factor it, because all I wanted you guys to do was find the function value. Like, this is the function value. Yes.
Would we not take out like 2?
I mean, we could, but we're trying to, right?
Why do you multiply instead of that?
Where? It's negative 2 times f of x, so I'm taking negative 2 times my function value. Yeah. Okay. So, I redid the notes for the second part of this lesson. Sorry, the hole punch. I know. I should hole punch these really fast. Because I brought my hole punch. Okay. So as I read this, I'll punch it out and I'll give it to you. So, a function with an unspecified domain is called the implied domain. It's the set of all real numbers for which the expression used to define the function is real. Alright. Andy, do you want to pass these ones out? There's going to be multiple. Yeah, just pass them down. Here's a couple more. Yeah, perfect. Because this, yeah, this is better than what I had. So,
Yes, and the homework problems are the same.
yes, they are. It's the same. This is just a little longer. Perfect. Thank you for your help. All right. So you'll notice these notes are a little different. It just breaks it down further because I realized I didn't have enough examples of all the different ones. Did everyone get one? Yeah, perfect. Okay. Thank you. All right. So, perfect. Going to open this up.
So only this one chapter.
It's only this one section that's different. Yeah. It's only the second half of section 1 because this is better than what it was. Okay. So, a function with an unspecified domain is called the implied domain, which is a set of all real numbers for which the expression used to define the function is real. So, blah, 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 what this means is you must exclude values from the domain of a function that result in division by 0 and taking the root of a negative number. So that's what we were talking about at the beginning of class. So this is like, this first little box is the same as what was in your notes, but this is better. All right. So for instance, here, I have a fraction, and I know the bottom, I can't have it be dividing by 0. So for which number, if I plug it in for x, would it give me dividing by 0? Would I have an undefined y value? Negative 2, right? So I know the bottom, x plus 2, cannot equal 0. So subtract 2 on both sides. I know x cannot equal negative 2. So what I do is I literally have to just cut that one portion out. So we went over interval notation yesterday, and this U is union. Remember, like a wedding union, the nuptials, the union of two people literally joining, the union of two peoples of joining. Union workers, like the coal miners, literally everyone joins together. So if you're having a union between two intervals, you're sticking the two intervals together. So all I'm doing is I'm saying, hey, the domain, the x values I can plug in are going to be any x value except the one I literally cut out, which is just negative 2. Have you guys ever seen like a VHS or cassette tape or like, no? It's okay. They were old when I was a kid as well.
Yeah, I remember them.
So what used to happen is like literally the way they used to edit before computers, they'd have these long stretches of tape, and then like, okay, they would like literally cut part of the film, and then they would take the rest and like merge it together. So that's kind of what I think of this as. Imagine like a giant line, and all I'm doing is cutting out the portion where negative 2 is, and I'm sticking everything back together. Whatever. Visual. I'm a visual person. I gotta see it. Okay, so we figured out literally it's just gonna be the place where I'd make the bottom go to 0. And then if I have this root, so I know the square root is going to be, it's gonna look something like this. Looks something like this, where this is 2. So notice, what are the y values when x is less than 2? When x is on the left of 2, what are the y values? Over here, what are the y values? Huh? It's not defined. Literally, it starts right here, and then it goes on to the right. It's not defined for values less than 2. Literally, the graph doesn't exist there. So the domain, the x, is only going to be from 2 to infinity. So the way we figure that out is we set whatever's inside the radical greater than or equal to 0. And this is only for even roots. So I see x has to be greater than or equal to 2. So my domain is literally going to be 2 to infinity. 2 to infinity. We're including 2 because I can plug in 2. Square root of 0 is 0. That's fine. Was that your question?
I have a question about the first one. Why would it go from negative infinity to -2 and then -2 to infinity?
So it's literally going to be all the numbers. So my x values I want to plug in are all the numbers except at -2. That's the one number I can't plug in. So
Oh, that's what the piece is. That would be like
yeah. This would, okay, so the graph of this one, this is technically a removable discontinuity, which we'll learn about later. The graph of this is going to be, the graph of this would look like this. Oops, it's on the wrong side. That's what it looked like. You don't know what that is yet. Maybe you do, but I'm not expecting you to know what it is yet. But this right here, this line is representing any of the x values I could plug in. You could plug in any single one except the one that would make the bottom go to 0. Because dividing by 0 means it's undefined. I only want the x's where it's defined, huh?
When something is undefined, does it mean that it just doesn't exist?
Yeah, it's literally a hole. Yeah. So if I have, so I could have so I think you guys went over this last year in Algebra 2 with piecewise. Piecewise is very important. So literally you have a hole in your graph and you can like keep going. It's just, oh, it's literally just, it's not defined. There's no y value for that one x. Yeah. Yep. So this is for only even roots, which I'm gonna go over. That's the big reason why I printed this insert, is because I didn't specify that enough in your original notes. Okay, so we're gonna, yes.
For those ones as well, so
I'm sorry, what?
for the ones that you just went over, for the first one, how do you know that it doesn't?
So I'm gonna go over all of these in more detail. This is just 2 quick examples, and I'm breaking it down further into polynomial functions, rational functions, which are the fractions, and then radical, which is the roots. So we're gonna go through them in more detail now. Does that answer your question or no?
I can see.
Okay. Hopefully this part will help more. All right. So polynomial functions. The domain for any polynomial function is all real numbers. So you say -infinity to infinity for the interval. So interval notation with infinities. You can actually pin them down. So that's why you have to have parentheses. With things that we can pin down. So for instance, x can equal 2. That's why we have the bracket, because we include it. Parentheses means you don't include it. Bracket is same as filled in circle. Parentheses is same as open circle. Okay, polynomial functions. Domain is all real numbers. So we can state the domain of each function. What's the domain of A? Yeah, -infinity to infinity. This is a polynomial, right? It's literally all real numbers. The only time where you have to cut out numbers is if you're going to be dividing by 0, or you're taking a root of a negative number, an even root of a negative number. Places where the y is not defined, where if you plug in an x, it won't give you a y. So this is a polynomial function, right? This left one, this is the same thing as 3x minus 12. It's just a line, goes on forever. All right, how about B? This is a quadratic. You know, a quadratic goes on forever. If I could like zoom out and see the graph and it's the size of California, literally, still just goes on forever. The domain is going to be all real numbers. So you go from negative infinity to infinity. So I want interval notation, but I'm like showing you these mean the same thing. Right? All x values for these functions, literally any x value you can come up with in your head as long as it's a real number, right? Not in the imaginary realm, it will work. So that's the easy one. Literally, if you have a polynomial function, domain's all real numbers. So we're just talking about the x values, the domain. So rational functions. The rational function is literally you have a ratio, a polynomial over a polynomial. And you know already, sometimes polynomials are zero value, right? Remember the solutions, the zeros, when you cross the x-axis? So a rational function, the domain of a rational function is every number except the zeros of the denominator. Because that would mean you're dividing by 0, which is undefined. So first, I want to know, where does this bottom go to 0? So this time I will have to solve. I have to solve for the zeros. Zeros, solutions, roots, those are 3 words. I mean the same thing. So Shane, what was your idea? Huh? How do we go about it? We have to factor. All right, let's factor it out. So what adds to 1 but multiplies to 12? 3 and so negative 3 and positive 4, right? Because that would 4 plus negative 3 is 1, yeah. Okay, and then to actually solve for what x would be, you take each factor and set it equal to 0. So you have x minus 3 equals 0, add 3 on both sides, and you see x equals 3. Take x plus 4, set it to 0, and you see x equals negative 4. Those are the 2 solutions to the quadratic on the bottom. So wait, if I plug in 3 into my original rational function, that means I'll be dividing by 0. Cannot do that, right? It's undefined. So I have to cut it out of my domain. I don't want 3. Cut it out. I don't want 4, negative 4. But I want all the other x values possible from negative infinity to infinity, just not those 2. So the way I would have to do it, sorry, let me slow down a sec to make sure you can write it. So these are the values that make my denominator equal to 0. So what I want all numbers except these 2, because these are the only 2, when I plug them in, would make the bottom of my fraction be 0. But I want any other number, just not those 2. So the number the thing I drew on top with those 2 holes, that's representing the domain of my function. It's literally all real numbers except negative 4 and 3. So to write this in interval notation, so you could write this as all real numbers, but x cannot equal negative 4 and 3. That's one representation. But what I want to do is write it in interval notation. So I go from negative infinity to negative 4. But I don't want to include negative 4 because that would make the bottom of my fraction go to 0. Sorry, this is like spacing out. Oh my god. This is like 1998 internet lag right here. It's like 5 seconds long. This is horrible. Negative infinity to negative 4. And I don't want to include negative 4, so I have a parenthesis. Then I need to include the section between my 2 zeros, right? I have to include this section right here. So how would I write this as an interval? Union, right? Because we're going to join multiple things together. Union. Then negative 4 to 3. And I don't want to include either one of those. So that's why I have parentheses. And lastly, union 3 to infinity. Oh my god, that's so ugly. I got to rewrite this. Negative 4 to 3, union 3 to infinity. What?
Why do we have to write the -4?
The part between? If you don't, you're cutting out all the x values between them. If you don't write that section. Yep. So this section is done by this part. Here is that part, and here is this part. So that was like your first time with 2 unions. Crazy. First time of probably at least 100 in this class. Awesome. Let's go. Are you ready for the next one? Nah. Okay. Let's go to the next one. Do you need more time to write? Okay. So this is a rational function because it's a ratio, a fraction of 2 polynomials. And I know the x values for polynomials are negative infinity to infinity, right? All real numbers. What I need to do is just cut out the places, the x values that would make the bottom of my fraction go to 0.
It's the exact same thing.
Surprise, it is. So I have to factor t squared minus 1. T squared minus 1 is a 3 words, blank of blank. Difference of squares. Do you like this game? It's kind of like Wheel of Fortune, but it's not at all. Difference of squares. T minus 1 and t plus 1. Oh my gosh. And I know it can't be 0, right? My bottom should not equal 0. So I'm looking for the values it cannot equal. T cannot equal 1 and -1. So I have to cut out. Those are the only 2 places I have to cut out. So those are the 2 places where I'll have unions. Right? Negative infinity to -1, union. -1 to 1, union. 1 to infinity. All I'm doing is cutting out the places. The unions occur at the places where I'm cutting out. Okay. So I'm just drawing a little number line. -1 to 1. Oh, to 1. So any number, as long as it's not -1 and it's less than -1, any number between -1 and 1, and any number bigger than 1, I could put in any of those. Right? If you think of a number 0.5, I put in 0.5, it gives me some number. I don't care what it is. 2, plug in 2 for t. That gives me some number, right? I'll have a y value. -5, 0.43, 0.1. All of these numbers are fine, right? They would literally give me a y value. But if I would plug in 1, I get 3 over 0. No bueno. I plug in -1.
Oh,
I get 3 over 0. No bueno. What? It's not all real numbers. I have 2 holes. Literally, x, I'm sorry, t, no, not yet. So I have to say, okay, negative infinity to -1, union, -1 to 1, union, 1 to infinity. All right, all I'm doing is I'm just cutting out -1 and 1. Stressing this heavily because people mess up on this last year a lot. And I want you to understand it better. So if you are a junior and you take calculus next year, you will know it. You have a question?
Yeah, so for these you just ignore the numerator.
Yeah, I don't need it. I don't care. It has nothing to do with my x values, my domain. My domain only depends on the bottom. What? No, I mean well, because that tells me what x can't be.
But no, but what I'm saying is I think that it would be that zeros would be -1 and 1.
They are.
But if you look at the numerator, one of those causes the numerator.
So this is a special case we're gonna cover next time, and maybe not next time, soon in this chapter. So in part C, there's gonna be a vertical. There's gonna be an asymptote where it looks something like this. Do you see the graph I'm trying to do? It's like hyperbola, hyperbole, hyperbola. It's a hyperbola because hyperbole is in English. It's a hyperbola, like 1 over x, or it's, you know what, I should just, nope, okay. Forgot that was there. So literally what C is gonna look like is something like this. There's 2 places where x not defined. One is because of an asymptote and the other is because of whole. You don't know how to do that yet. I'm gonna teach you. So the domain, we're only dealing with domain right now. We haven't touched vertical asymptotes or holes. So later, the top will actually come into play a little more, determining is it a vertical asymptote or is it just going to be a hole. So we're only looking at the bottom right now. I could even like black out the top because I only want to know where is x squared minus 1 equal to 0. Turns out, guess what? X minus 1, x plus 1, it's going to be the same thing as last time. Negative infinity to negative 1, just a moment. Union, negative 1 to 1, union 1 to infinity.
You know what I'm saying? Because of the way the top is formatted, it would end up being where one is a possible answer, because
It's
it
not.
would be 0 over 0.
0 over 0 is an indeterminate form. You haven't learned about that yet. Yeah. So the 0 over 0, it's called a removable discontinuity. It's the place where like you have a hole just randomly in the middle of your graph. That's where your removable discontinuity would be at. Sorry, it's actually going to be at -1, but you get the point. All right, question.
This is not related to this, but like to ask for the range, then would you use it?
This is not, okay, ask me in like 2 lessons about range. So we're focusing on domain, because those are the x values. The range would be once we've learned about horizontal asymptotes, vertical asymptotes, removable discontinuities, and like all this other stuff. Because then you're like, okay, cool. So like you have to understand all the other stuff first. Yeah, so first we're going to start with range, and then we'll deal with piecewise functions. We'll deal with x and y intercepts, symmetry, and when do we actually get to it? We don't deal with range until section 4, like 5, yeah. Okay, here is it the same thing as this one?
Oh, the plus one now.
No. So this one, I know the bottom cannot equal 0. Cannot equal 0. Oh my god. Load. So if I set x squared plus 1 equal to 0, x squared subtract 1 from both sides equals -1 square root. So literally the values that would make the bottom of, right, the denominator go to 0 would be, plus or minus I. So what that means, the numbers that would make the bottom go to 0 literally have to be imaginary. Which means if I plug in any real number, it will always give me a y value. It will never be undefined. So literally, if I would plug in imaginary numbers, then I could have a undefined, but any real number, I can plug in any real number, and it would work. Right? If I plugged in 1, what's 1 squared? 1 plus 1 is 2. Okay, well, what if I plugged in like -1, right? -1 plus 1 is 0, but -1 squared is 1. Plug in 0, I still have this 1. So literally, you can plug in any x value. You'll always have a number down here, it will never equal 0. So we say all real numbers. So to write this in interval notation, I say -infinity to infinity. Wonderful. All right, and radical functions. Fun. Give me a couple more seconds to write this down. Okay, so radical functions. The domain of a radical function with an even nth root is the numbers for which the radicand is greater than or equal to 0. So as long as it's an even root. So even roots are, let's see, the second root. Come on. So if we have a second root, well, normally we just square root. If I have a 4th root, 6th root, 8th root, you get the point. Literally even. All the graphs look something like this, where whatever's underneath here, you set it equal to, greater than or equal to 0. Because they're literally not defined for the whole left side of the graph. So that's for even. What if you have an odd nth root? So this is like a 3rd root, just a moment, or like a 5th root, a 7th root. Do we know what a 3rd root looks like? Maybe not. But if I put a negative, I can't put a negative under a square root, right? Because nothing times itself is going to be negative. any negative times itself, so negative times negative is always going to be positive. That's why you can't have a negative under a square root. But you can have a negative under a cube root. What is the cube root of negative 8? What times itself 3 times is negative 8? Negative 2. Negative 2 times negative 2 times negative 2 is negative 8. So that's fine. It's defined for all real numbers, right? So if I would graph a cube root function, it would look something like this. So wait, it literally, any x value could be plugged in here and I'll have a y. So if you have an odd root, the domain is all real numbers. You could put any x value under it. But if it's an even root, like a square root, you can't put in negative x values. Like you can't put in a negative x value and still have it like be negative underneath. All right, question? Did I hit your question? No. Yeah? Did you have a question? No? Okay, cool. You did, yes.
So for the radical functions, are those always going to start like on 0?
So regular square root like starts at 0, but this is going to cause some translations inside. So that's why we set whatever's inside the root. If it's an even root, we set whatever's inside greater than or equal to 0. So let's go through the first one. So f of x equals square root of 7x minus 70. So since this is an even root, right, this is the second root, I set whatever's inside my radical greater than or equal to 0, and I solve. 7x minus 70 is greater than or equal to 0. So add 70 to both sides, showing that this is a square root. It wasn't given. I'm just like reiterating, this is a second root, and 2 is even. Okay. Add 70 to both sides. 7x is greater than 70. Divide by 7x is greater than 10. We know how to write this in interval notation. So x can equal 10, but then it has to be greater than. So I start at 10 and I go to infinity. So the domain would be 10 to infinity using a square bracket. 10 to infinity. Notice square bracket with 10, parenthesis with infinity. That's it. This is the domain. Perfect. All right, let's try the next one. So I have to set whatever's inside here greater than or equal to 0. So x squared, come on, minus 2x minus 15 greater than or equal to 0. I can factor this out. So think what multiplies negative 15 adds a negative 2. So it'd be negative 5 and 3. So x times x minus 5, x plus 3. So that means I have 2 zeros. So this is weird. Like, what the heck is going on here? Do you know what the graph of x squared minus 2x minus 15 looks like? Do you know what it looks like? So this is a parabola, so it's a U shape. Question, is it facing up or down? How do you know? Up, because it's positive x squared. So it's facing up, and my 2 zeros are going to be at negative 3 and at 5. So this is the problem where we're n, because we have 2 more minutes left. So here's negative 3, here's 5, and I know it's facing up. So those are my 2 zeros. I know it's facing up because the coefficient in front of x squared is positive. And if you're positive, you're smiling. What about if you have negative coefficient in front of x squared? Right, if you're negative, you're frowning. It's literally a frowny face. So it points down, whatever. Okay.
Why wouldn't you just do this like how you did the other one with the...
Because there's a whole section where it actually can't be equal. So I'm looking, and I'm looking for, I only want the x values. I only want the values where it would give me a positive number. So any number between 3 and 5, if I would plug it in, would make the whole thing negative under here. So any value between negative 3 and 5 when I plug it into the quadratic, it would give me a negative y value, and I don't want to be negative. So I only want the portions where it'd give me a positive number, which is why it would just be negative infinity to negative 3 union, sorry, this should be square bracket, because I can put in 0, union 5 to infinity.
Would there ever be a time when they did want a negative?
Well, you don't want a negative under a square root, under an even root.
And wait, why do you know that you want positive?
So, okay, so if I'm looking for, instead of having x squared minus 2x minus 15, I could plug in different values, and I already know what it would be. It's literally the y. If I plug in 0, it gives me negative 15. Square root of negative 15, that's imaginary. I only want numbers that would give me a positive number under the root. So we're going to start here. Next time we'll finish this and we'll start 1.2.